Way more than that. Alright, let's do our lesson. So, today I'm going to do another thing that you've done before. Crazy. The only thing we haven't done yet, that you haven't done before we started this unit, was the interval notation. Today we're talking about graphing inequalities. I think you've done that before, haven't you? Yeah. Okay, it is very easy if you follow the steps that we tell you. Okay? I think it should be pretty easy, so let's go through it. So, before we do that, let's talk about, what's going on here? Alright, so look at progressions. First of all, we start with an equation, right? How many answers did our equations have? 1. If there's an absolute value equation, it had 2. There's a normal equation here, we had 1. If we're talking about just one variable, we had many solutions, right? We graphed it on a number line. There's only one axis on a number line. We're going to go today to 2 variables, where we have y and x in there, and we're going to go to a coordinate plane. Right? Our answers are going to look something like this. You're going to be like shaded in, but yep. Okay. So that's our progression so far. So a linear inequality describes a region of the coordinate plane that has a boundary line. Now, we're going to do things that look like the one on the left and the middle one here today, where we have just one line, we have part of it shaded. On Monday, so we're not doing anything on tomorrow, we're doing out of code. On Monday, we're going to get stuff like this one all the way on the right, where we have more than one line on our graph, and we're shading in between them, we're shading in certain regions. It's really not that bad, I promise. Okay? So, has everybody got this written down? I think there's a blank for this, isn't there? Yeah, we got that written down? Because it doesn't seem like everyone's paying attention right now.
Thumbs up, we got it.
Okay. So, before we do that, let's talk about how we graph a line. I know we talked about this the other day. How do I graph a line that looks like that? Y equals 2/3 x minus 4. Start at -4. That is my y-intercept. So where it crosses the y-axis at -4, I put a dot. What is my slope? 2/3. So that means I go up 2, over 1, 2, 3. Up 2, 1, 2, 3. Then I take my straight edge out.
Do you have to have a straight?
Yes. Hey, on test day, I have this nice, wonderful box of straight edges that you can all borrow if you need one. In your notes, that's it's up to you if you're using a straight edge, but on the test, if you have a janky line, it's going to get marked wrong. So please use a straight edge on the test. Use an ID card. Use the side of your calculator. I don't care. Shh. So, guys, remember, when I'm drawing my line, I think I talked about this a little bit when we reviewed it the other day too. Your line should go all the way through your graph. It shouldn't stop at any point on there. And what should be at the end of it? Arrows. Arrows. If you don't have arrows, it is getting marked wrong. Right? Your line keeps going. It'd be really crappy if you did the whole problem correct and you got it marked wrong so you didn't put arrows. Right? That would suck.
Played off or is it like wrong?
Wrong.
Oh. Your first born child.
Alright. What about this one? 5x minus 2y equals 10. Hey, there are 2 ways to do this, remember. You can use the cover-up method, or you can solve for y and get to say y equals mx plus b. What would you rather do?
Cover up. Not the cover up.
How is this? Let's do the cover-up, and then we'll solve it for y. We'll do both ways. Deal? Okay, so if I do the cover-up, that means I'm going to let x equal 0 for 1, I'm going to let y equal 0 for 1. So if I let x equal 0, this covers up, goes away, I'm left with -2y equals 10. Divide by -2. I get y is -5. So one of my points then would be 0, -5. So put that on my graph. If I let y equal 0, that -2y gets covered up, I'm left with 5x equals 10. Divide by 5. I get x equals 2, so 2, 0 would be my other point. At 2, 0, I'd put a point, and I can officially draw my line at this point. Do not forget to put your arrows at the end. Alright, if you prefer to solve for y, 5x minus 2y equals 10. Take and subtract 5x. I would get negative 2y equals negative 5x plus 10. And I would divide by negative 2 to solve for y. Y equals 5 halves x minus 5. So with that, I would take my y-intercept's negative 5. I'd put a point. My slope is 5 halves, so I go up 1, 2, 3, 4, 5 over 1, 2. Weird, it works out to be the same points. Probably a good thing, right? So, draw your line, put your arrows in. Either way works. If you do them correctly, whether you solve for y and do y equals mx plus b, or whether you do the cover-up method, you should get the exact same thing. Alright? Are there any questions about graphing a line? So if we can't do that, we can't graph inequalities. Okay, then let's graph some inequalities. So, if I have y is greater than negative 2x plus 5, step 1 is to graph the inequality as if it had an equal sign, or if it was an equation. Right? So I'm going to think about it either, in this case, I have like y equals negative 2x plus 5. I'm going to graph it like it was that. Well, where would my y-intercept be there? 5. So I'd put a point there. What would my slope be?
Negative 2 over 1.
Negative 2 over 1. That means I go down 1, 2 to the right 1. Down 1, 2 to the right 1. Now, before you draw your line in, you need to figure out if it's going to be a solid line or a dashed line. Does anyone remember how you determine between that?
Dashed.
Taylor?
The solid is the, like the, equal to one.
The or equal to?
Yeah, and then the non is the other.
The dashed line would be just less than or greater than. Less than or equal to or greater than or equal to would be a solid line. So in this case, we're going to have a dashed line. So make sure you put a dashed line in there. Alright, that's the first two steps. Graphing it as if it was an equation and drawing a line. The third step is to take a test point. Now I know some of you do the trick where you determine which way the thing goes, right? Whichever way this goes. I don't know how to do that. I don't know how to do that. I was never taught that. If it works for you and you know how to do it, go ahead and do that. But I'm going to show you the way that I was taught and the way that we've been teaching everybody. Alright? So take a test point that is not on the line. The easiest test point to use, because you're going to plug it in for x and y, is going to be 0, 0. Right? So I'm going to take the test point of 0, 0 because it is not on the line. Let me rephrase that one more time. It cannot be on the line. Your test point cannot be on your line. So if 0, 0 is on the line, you need to pick a different test point. Alright? Otherwise, I would stick to 0, 0. So choose a test point not on the line. Substitute x and y into your original inequality. 0 greater than negative 2 times 0 plus 5. Well, what's negative 2 times 0?
0.
0. So 0 is greater than 5?
False.
Is that a true statement?
No.
No, it is false. Which means you're going to look at your test point. If it is false, I'm shading the opposite side of the line. So in this case, I would shade the graph over here. If it is true, you're going to shade the side of the line with the test point on it. And you're done. That's it. That wasn't bad, was it?
No.
Do you have any questions? Oh, we're running out of time quickly. We really got sidetracked today. All right, let's try another. In standard form, 3x plus 3y equals 12, right? Think of it like that. Okay, let's solve for y, because I know most of you like to do that. So I'm going to subtract 3x to both sides. I get 3y equals negative 3x plus 12, right? I'm thinking of it as it's an equation, so I can actually graph it. Divide by 3. y equals negative x plus 4. Alright, so if I go to graph that, my y-intercept is at 4. My slope is negative 1, which means down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. Now, when I go to draw my line, is this going to be dashed or solid? Dash, right? It is just greater than. It's not or equal to. Alright, I'm going to take a test point. I would like to take 0, 0. Is that okay for me to take in this case?
Yes.
Yes, because it is not on the line. So, test point, 0, 0. I plug it into my original one up here. I get 3 times 0 plus 3 times 0 is greater than 12. Well, what's 3 times 0?
0.
0. So I get 0 plus 0 is greater than 12, or 0 greater than 12.
False.
That's false, right? So we're going to shade the opposite side of the line from our test point. Yes, Andrew's question.
Can you plug in the test point for the y equals negative x plus 4?
No, because then we have an equal sign in it, right? If you had kept your greater than symbol through the whole thing and you had done greater than whatever, so you give y is greater than negative x plus 4, then that'd be okay to plug it into. But that gets really tricky when you like end up like dividing or multiplying by negative, your sign starts to flip, things like that. So you just have to be very careful then. Like if I'm solving through here, and you get y, and I divide by a negative, my sign would have to flip the opposite way, just like it normally would.
Yeah.
So just be careful then that you are flipping your sign if you're going to plug it in at the end, okay? Alright, any questions? Yes, no? No, we what? How many more? Do a lot more or just 2? 5? Oh, I think we have, alright.
Those are like
Are the other ones?
only 3.
I see this.
On the bottom
Alright, so we're going to do one more of these, and then we're going to go to the back side. Alright, so y is less than 4/5 x minus 1. Graph it like it's an equation. Y equals 4/5 x minus 1. Alright, so y-intercept at negative 1. Slope of 4/5, up 1, 2, 3, 4, 5, over 1, oh, excuse me, up 1, 2, 3, 4, over 1, 2, 3, 4, 5. Is this line going to be a a dashed or a solid line? Dash again, it's just less than. Alright. Test point, 0, 0 is not on the line, so we're going to use it again. 0 less than 4/5 times 0 minus 1. I get 0 is less than negative 1. Is that a true statement?
No.
No, so I shade the opposite side of the line to my test point. Guys, if I can't tell which side is shaded, it's going to get marked wrong. Right? So you make sure you shade it in enough. Alright. Any questions so far? I'm on the wrong spot here. Alright, we are going to skip the next two. Here on school, would you guess?
For 4 though, it doesn't have an x.
Do you want to do that one quick? Alright, if I give you the equation, y is greater than or equal to negative 4, and I rewrite that as an equation, y equals negative 4, what type of line is that going to be? Horizontal, right? Y equals negative 4 is a horizontal line. Because y equals negative 4 here, and here, and here, and here, and here. Is it going to be a solid or dashed line? Solid. So, same thing then. Take a test point, 0, 0. Test point, 0, 0. If I plug it in, I get 0 is greater than or equal to negative 4. Is that true? Yes, so I shade this part up here. How much time do we have? 5 minutes?
Do
Okay.
we have to write test point or do we just?
No, you don't have to write test point. If you shade it incorrectly, it helps me to see what test point you used or like what you plugged in. So just show your work on what you plug in. I should be able to figure it out. Okay. All right. Shh. Any questions? Okay. Let's try one of the writing equations. Maybe we'll have time for two. So we're looking at a couple of examples. We're going to write a linear inequality that represents the graph. Let's think about that. How can we do that? What? It's solid, so I know it's going to be or equal to, so that's helpful. But if I want to write an equation of a line, what are the two things I need?
Y-intercept, slope.
Y-intercept and slope. Well, if I look on here, where's my y-intercept? 2. What's my slope? What does it turn out? Is it 2 over 1? Okay. Up 2 over 1. So slope is 2 over 1 or 2. So when I go to write it, I'm going to look and see, well, y equals 2x plus 2. But I don't want an equation. I don't want an equal sign. I want an inequality. Well,
Plug in 0.
plug in 0, 0. Right? I know it has to be true because that side is shaded. So if I plug in 0, 2 times 0 plus 2, well, I get 0 and I get 2. Which way is my inequality have to go? It's got to open towards the bigger number, right? Because it's got to be true. So I know it's a less than or equal to. Does that make sense?
Yes.
So my actual answer then is going to be y is less than or equal to 2x plus 2. Does that make sense? How we did that? All right, let's do the last one quickly. What's my y-intercept in the second problem?
3.
3. So b equals 3. What is my slope?
-2.
Down 1, 2, 3, 1, 2, 3, 4. -3/4. If we were to ask you a question on tests like this, and you can't tell where like it hits another point, please come and ask. I'm not trying to trick you, right? So yes, it's tough to see on some of them. It should be -3/4. So I get y -3/4 x plus 3. Once again, plug in a test point. I know if I plug in 0, 0, it's got to be a true statement. Right? So I go 0, -3/4 times 0, plus 3, 0 and 3. So which way has it got to face? It's got to open towards the 3, right? So it's a less than. Is it or equal to? No, because it's a dashed line. So y less than -3/4 x plus 3. That will be my linear inequality. All right, does that make sense? I know it went really quick. Do we have any questions? All right.